Okay, so here we're going to parametrize a line. Now I'm going to parametrize it in a very specific way, right? So the example asks to parametrize a line from 3, 0 to -2, -5. So the line is at 3, 0 at t equals 0 and -2, -5 at t is equal to 1. All right, so let's kind of outline here what we want to happen, right? So we have an axis here, so we're at 1, 2, 3, 0, so that's our first point. Next point is at -2, -5, 3, 4, 5. Okay. All right, and the next point is down here. All right, and we have the line segment going from here to here. All right, and I want to have it in such a way. Remember, we have a sense of direction when we parametrize curves. So what I want is I want the line when t is so essentially to start here and make its way here. All right, now a way to parametrize a line. Remember when we have in Cartesian coordinates, we have this, right? Y is equal mx plus b. Now we can use the same kind of idea where m is the slope, right? Now the slope captures two quantities, right? The change in y and then the change in x. So I'm going to take that same approach here for my parametrization. So what I can do is the x of t, since that only focuses on the horizontal change, the way I'm going to parametrize any line is I'm going to use delta x times t and then plus my initial point, right, where it starts, right? And then y of t to just encapsulate the change in y times t, right? Because that's what's varying, right? As t progresses, it changes, right? And then the initial point y0. Okay, now for this particular example, the x0, y0, I have 2 points to choose from, but they're asking me that I want it to start at 3, 0. So x0, y0 is going to come from the point 3, 0. If I wanted to start at the other end, then I would choose -2, -5 as my endpoint. Okay, now the change in x and the change in y is going to calculate the same way, right? Delta x, right? I'll do the change in the x from the end to the beginning, so -2 minus 3, so that gives me -5, and then delta y will give -5 minus 0, which gives me -5. Okay, so here, so now to write the parametrization, we'll have x of t will be delta x, which you saw -5, times t, which is our variable, and my starting position, which we have to be plus 3. All right, and then y of t, delta y, which here is also -5, right? That won't always be the case there. And then plus 0, you can leave it like that, or here just to see, it's plus 0, right? From our starting point 0, 3. Right now, as you can see here, and here in both cases, right, we want t to run from between 0 and 1. Okay, and that's how you would parametrize this curve, right? And as you can see here, if we lay out a table of values, t, x of t, y of t, we'll look at just the two endpoints, right? When t is 0, what do we get here? So these values are 0, x is 3, y is 0, as desired, right? That's we wanted to start there. When t is 1, right, that's at the end of our domain. When we plug in 1 into x, x of 1, we get -5 times 1, which is -5 plus 3. That gives me -2. And then -1 times -5 is -5. And you see that is our input. So that is, in fact, how we parametrize any kind of line. You can do it in this manner. All right. So that's how we focus on parametrizing a line segment, I should say. If you just wanted the whole line, right, then t would just be from negative infinity to positive infinity. Restricting the domain just restricts that. Now it's the line segment and not the full line. All right, now let's learn to parametrize circles and ellipses. So as it turns out here, whenever you have an ellipse here, a circle centered in the origin, it will always have this this equation, right? Now, very similar to our Pythagorean identity, which we know to be cosine squared, I'll use t here, plus sine squared t equals to 1. So I want to kind of generalize this to, let's say I had a circle of radius 4, right? How would I do that, right? Well, I'm going to work off of this identity. If I multiply through by r squared, so we can have r squared cosine squared t plus r squared sine squared t equals to r squared, right? And in particular, we can rewrite this as r cosine t squared plus r sine of t sine of t squared equals to r squared. Right? So in general, when we have an equation that's of this form here, right, a circle, the parametrization that I'm going to choose, I'm always going to choose this, right? I'm going to say, almost always, right? X of t equals to r cosine t, right? Again, whenever it looks like this, and then y of t is equal to r sine of t. Right, and what that would lead to the parametrization of this curve that is going in a counterclockwise direction. Okay. All right, so if we have, for example, I want to parametrize x squared plus y squared is equal to 16. So the important part here is that we identify this as a circle with radius 4. So right away I can jump here to the parametrization of x of t being 4 cosine t and y of t being 4 sine of t. All right, and that's how we parametrize a circle centered at the origin. Now, in a similar vein, we can parametrize a ellipse. So, general equation of an ellipse looks something like this, right? X squared centered at the origin, x squared y squared, and divided by some factor, right? So the graph of this looks something like this: 2, 3, 4, 5. So whatever the root of this is, that's the length of what we call the major and minor axes, the bigger one being the major axes. So here this goes up to 5 and negative 5, and then 4 goes 1, 2, and negative 2. So that looks something like this. All right. Okay, and the one difference here is where before we had just a radius, right? We don't have a radius here. We have a different change in the x and the y, right? It's an ellipse, right? So kind of like an oval type shape. So the parametrization for something like this will always take the form of, for my x of t, I'll still use the cosine, but instead of having the same value for the x and the y, it's going to differ. it's going to depend on what you're dividing by. For this being 4, then I'll take the root of that. So I'll have 2 cosine t for the x, and then for the y, we'll have 5, the root of 25. 5 sine of t. All right, and that yields the parametrization where we go in that direction, in the counterclockwise direction. Okay, so that's how we parameterize a couple of curves here, right? One being the line segment, and the other being a circle or an ellipse.